How can we derive the coordinates of the unit circle? Now, if you'll recall from aim 9.1, toward the end, I brought up the fact that the unit circle is symmetric. We're going to use that fact in order to determine these coordinates. So the do now says, given the following triangles, if we made the hypotenuse equal to 1, how would this affect the other sides? Well, let's see. So now, how do we shrink these two special right triangles? Notice that we want each one to have a hypotenuse that's equal to 1. So let's start solving for that. Now, normally I would write in pencil, but I want you guys to be able to see what I'm doing. So I'm going to start writing in pen. So we're going to make 2a equal to 1, and we're going to make a times the square root of 2 also equal to 1. So now, for the first one, we are going to solve for a. So now, if we know that 2a is equal to 1, we can determine that a is equal to 1/2. And now, if a is equal to 1/2, it follows that you can add 1/2 here times the square root of 3, or square root of 3 divided by 2. And also here, a is 1/2. So now we have derived that when the hypotenuse is 1, the side that is opposite 30 degrees is always half the hypotenuse. So this will be 1/2. And the side that is opposite 60 degrees will be the square root of 3 divided by 2. And this ratio holds no matter what the orientation of this triangle is. So now let's move on to the 45-45-90 triangle. So here, in order to solve for what a is in this case, we're going to make 1 is equal to a times the square root of 2. And now to solve for a, we divide both sides by the square root of 2. However, we like to rationalize our denominators. So I'm going to multiply both the top and the bottom by the square root of 2. Notice that by multiplying by the square root of 2 divided by the square root of 2, I'm simply multiplying by 1 because they simplify to be 1. So this is now the square root of 2 divided by 2. We can now take this information and add it here. The square root of 2 divided by 2, and the square root of 2 divided by 2. So now, when we've dilated that special right triangle, we now have that the hypotenuse is 1, and that the two sides of this equilateral right triangle are the square root of 2 divided by 2, and the square root of 2 divided by 2. Okay, so now let's move on. So now with that information, let's look at a unit circle. We have the 4 quadrants that are marked off in degrees and in radians. So notice here that because this is a unit circle, all of the radii are equal to 1. So this has a length of 1. However, if this were a coordinate, it's going 0 on the x, but it's only going straight up on the y, so its coordinate is 0, 1. This one here is 1 unit, but it's to the left on the x-axis, and it's not going up any. So its coordinate is -1, 0. This one will be 0, -1, and this one is 1, 0. So in a previous lesson, we learned that 30 degrees is equivalent to pi divided by 6. So now we're going to take the information that we just learned about those special right triangles, and we're going to add that information here. So the length that is opposite 30 is 1/2 the hypotenuse. And the side that's opposite 60 is rad 3 divided by 2. Now, if this were expressed as a coordinate, it would be as follows. The square root of 3 divided by 2, comma, 1/2. This is because a coordinate is the distance that your point is from the origin. So here, you've gone over the square root of 3 over 2 on your for your x value, and then you've gone up 1/2 for your y value. And that's how we get this coordinate. Now let's say that we reflect that coordinate. If we reflect that coordinate, this new degree be 150. However, the reference angle is still 30 degrees. And the height is still 1/2. Notice that in the first and second quadrant, your y values are positive. However, in the second quadrant, your x values are negative. Now, we don't consider distance to be negative. So you can think of this negative sign as an indicator of your direction. So here, your new coordinate would be negative square root of 3 over 2, comma, 1/2. Notice here that your x is now negative because in the second quadrant, your x values are negative, while your y value stayed positive. And the corresponding radian value is 5 pi divided by 6. Now, let's take our second angle and let's now reflect it over the x-axis. We now get the following ratio. Negative square root of 3 over 2, because in the third quadrant, x is still negative. However, also in the third quadrant now, y also becomes negative. So both the x and y values are negative. And the radian measure is 7 pi over 6. And now let's reflect this last one over the y-axis. We get the following. Notice in the fourth quadrant, your x values now become positive, while your y values stay negative. Of note, all of the coordinates have the same numerical values. The only thing that has changed is the fact that some are negative, some x's and y's are negative, depending on their location. And it's also listed here in blue, what I just said. Also, notice that this makes a lovely bow tie or butterfly. You'll know that you have reflected appropriately with the correct reference angle if your measurements are symmetric. So now let's look at that same 30, 60, 90 triangle, but from the perspective of 60 degrees. So the side that's opposite 60 will be multiplied by the square root of 3, whatever the side is that's opposite 30. So notice here that this portion, the top angle, must be 30 degrees. So if your hypotenuse is 1, the side that's opposite 1 must be 1/2, making the side that's opposite 60 degrees the square root of 3 over 2. So now, what is the new coordinate? Well, it would be 1/2, comma, square root of 3 over 2. And the radian measure for that would be pi divided by 3. Because this is 60 degrees, you can think of pi as being the same as 180. So 180 divided by 3 is 60 degrees. So now let's reflect that over the y-axis. Notice that the x value now becomes negative because we're in the second quadrant. And your height is still the same because your height has not changed when you reflect over the y-axis. And now this is a radian measure of 2 pi over 3. The equivalent degree value here would be 120 degrees, and 120 degrees, the reference angle for it, is indeed 60 degrees. So now let's take this angle and reflect it over the x-axis. When we do that, we get negative 1/2, comma, negative square root of 3 over 2. Notice how the coordinates are repeating themselves. The only thing that changes is the positive or negative depending on your location. And over here, the radian value would be 4 pi over 3. And now we reflect it one more time over the y-axis. And here we get 1/2, comma, negative rad 3 over 2. Notice how your x values have not changed, neither have your y values. The only thing that changes is whether or not it's positive or negative, depending on the location. And now let's look at the 45, 45, 90 triangles, or pi over 4. So here we have an isosceles right triangle. So if the hypotenuse is 1, the two sides are the square root of 2 divided by 2, and the square root of 2 divided by 2. So what would that be, that coordinate? The square root of 2 over 2. So now let's take this and reflect it over the y-axis. Notice again, the only thing that changes is the positivity of your x value. It now becomes negative. And now we can do the same by reflecting this triangle over the x-axis again. And now both x's and y's are negative in the third quadrant. And in the fourth quadrant, only the x is positive. And so here, we'll notice that we have a lovely bow tie or a butterfly that has been formed. And here is a complete shot of what your unit circle would look like. And your homework is done.